do it. Hello. Let's start. So we're going to talk today about application collection, one-stop shop for enterprise-grade artifacts for all container needs. I'm François-Xavier Wa, but I don't expect anyone to pronounce François-Xavier. That's what I go by FX. I am product manager. I focus on open source applications through containers and Helm charts. So that's application collection. I have an interest on secure build and software supply chain, and you're going to hear a lot of that today. And I also take care of SUSE BCI. I live in Switzerland, so I'm very neutral. Don't ask me to go into any polemic topic. And I'm father of two, so why I could not put any hobby there. I don't have any anymore. How many of you have seen this slide during SUSECon? I think we were supposed to all use it. No, I was just checking. So, you know, SUSE, for the last 25 years, we have really much been focused on uplifting, the open source ecosystem to enterprise-grade consumption. And we are a leader in the community space, so we needed, and we owed to the community and to our customers to have a vision on what are those elements that we're going to focus on to uplift open source consumption to enterprise grade. So we did our research, and we come up with those 5 pillars of focus for everything we do. We know that it's complex, Kubernetes. And this complexity is a challenge for our customers. And having support and simplification through management platform, etc., is something that helps. That's what we focus on very much with Runtime Manager. The second one, multi-cluster, multi-cloud, and silos. The promise of Kubernetes is very much the abstraction toward the hardware layer. And this promise is, by many means, addressed through the principle of Kubernetes. But when it comes to multi-cluster, multi-silo, multi-cloud, it's a little bit more complicated. Since day one, Runtime Manager has been focused on being a multi-cloud management platform so that you can have this abstraction layer so you can really manage all your clusters in a cohesive way with a single pane of glass. That's how we help the community and our customer to address the challenge of the multi-cluster world. Cloud-native security. Security is hard. Security will always be hard. And in a cloud-native space, we needed to adapt. You lose kind of observability, natural observability feature in the cloud-native world because things spin up, spin down. IP is not necessarily predictable. We needed to have and to provide our customers with tools that are context-aware in the community space. But we also needed to work on the supply chain security, the left side of the story. That's what we're going to talk a lot about today. Scalability and flexibility. Of course, Kubernetes is all about scalability and flexibility. And that seems like a dream in many ways, but scalability and flexibility is also about being able to maintain observability at scale, to enforce policy at scale, to do management at scale. And this is where we're trying to help, of course. And the last topic, experience and learning curve. We know that our customers have many teams working on Kubernetes. We really want to empower them to build their experience and their knowledge to be able to apply them on other parts of their organization. So we foster flexibility in team assignment, and as a contributor to those teams, you'll learn something that is applicable everywhere. So those are the stuff that we are trying to help our customers with in the context of cloud native. And you're going to see that application collection is also about that. So open source applications in the wild, so that's the agenda. Open source application in the wild, trusted open source software procurement, and in practice, what it's about, how does it look like. Open source application in the wild. So containers in the wild, it's a dangerous place. When you use a container, container image or Helm chart from an untrusted upstream source, you're going to have many challenges. First of all, you don't know who built it. It's when you do Docker pull something, who actually built it? What kind of guarantee you have that the build pipeline that has been used hasn't been tampered with? How secure is it? What kind of commitment does the provider have? You have the issue of lack of standardization, because if you go, once again, if you just Docker pull something, you may come with very different implementation, with very different interpretation of the OCI specification, etc. That poses a problem. If you don't have standardization, you will not be able to automate. You will not be able to have policies that's going to be enforceable at scale. You need standardization. Lack of maintenance. Of course, if you pull an application and you expect to be the latest version of this application, if you pull the tag latest. But are you sure that all the transitive dependencies in the container have been updated? If CV have been fixed after the release of the flagship application? A typical container application usually have between 40 and 50 packages. The maintainer of this container may just focus on the flagship package. If you do Docker pull MariaDB, yeah, maybe you're going to have the latest version of MariaDB and it's CV proof, but all those 40 applications that comes with it may have CV that hasn't been solved. That's something that is a real problem, a real risk, and a hidden spot in many cases. Lack of enterprise class features like thieves, LTS, and things like that, and altogether risks. That's the problem with consuming containers and so on. And that is somehow something that is quite different from what we used to see in the legacy world. In the legacy world, which was very much an operating system vendor-driven world, when you wanted to install an application, say MariaDB, you do zipper install MariaDB. But without even caring about it, you actually pull it from the repository of your OS vendor. And if your OS vendor is an enterprise-grade OS vendor, like us, you will have something that is on par with the rest of your system, and that follows the principle, and you may have some contract and commitment. But the container space is very much driven by developer approach. And that's very good. That's why we love it so much. That's why it empowers developers for more flexibility and autonomy. But the trade-off is that when you pull something, you don't necessarily pull it from somebody with which you have a contract, somebody that is audited, that is certified or anything. That's where we need to come into play. But that's not all. Actually, that's just the beginning of the story. So we talk about container and how inside a container you may have risk, you may have uncertainty, you may have blind spots. It's already a challenge of its own. But whenever you talk about an open source Kubernetes application, you're not talking just about one container. You may probably interact with one Helm chart. You do Helm install, and it seems like something simple. But this Helm chart may refer to several subcharts. And those subcharts may all refer to different containers coming from different sources. They may have been built by different persons. We live in the open source world, so of course you reuse stuff that are available. So that makes it for a perfect recipe for heterogeneity, which is not controlled, maybe lack of alignment, lack of standardization, and then it becomes difficult to control anything. So that's the problem with pulling an open source application for Kubernetes. But usually you don't have just one application. If you build a corporate Kubernetes application, traditionally you would need an identity provider, you would need a database, a data stream, I don't know, an API gateway, this kind of stuff. Each of them, if you do not pay attention enough to where it comes from, if you just install them through untrusted repository or registries, they may all come with a different interpretation of the OCI standard. They may all come from sources that have different approaches in terms of supply chain security. You may not know what you're pulling. So the problem is even bigger when you talk about building a corporate Kubernetes application, because it's multiplied by the number of applications inside the number of components, open source components inside your Kubernetes application. And of course, all of that percolates down to organizational challenge. A typical organization has several teams. All of them create Kubernetes applications. If they not operate on a standardized way, with a trusted source that everyone is relying on, the learnings from one team may not be applicable to another one. So that's a missed opportunity for flexibility in the workforce. That's a missed opportunity also in synergies, in building components that are reusable, and difficulties in automation, of course. And at corporate level, you may want to have policies that are enforced for everything. How do you do that if the metadata, if the annotations, if the labels, if all those good things that comes with Kubernetes artifacts don't have the same interpretation, don't have the same quality of data? So that's why we think we really need to provide something to address those challenges. But it does not happen anytime. We live in a very specific point in time. We live in what I call the fight against the mad software days. Maybe you remember the mad cow disease. That's a point in time where, yeah, but you remember? Yeah, that's why. Anyone here has heard about mad cow disease? Okay, that went out of the, that goes out of the UK border, I guess. So when the mad cow disease happened, we just started to figure out that we need traceability. We need to know where the cow comes from, basically, where the meat comes from. And given the transformation chain that you have from the original cow to the end product, it was difficult to rebuild trust. So we needed to reinforce the processes. We needed to reinforce the traceability. We needed to have regulation to enforce that. And we live in the same world now, but now it applies to IT. I consider that the beginning of the fight against the mad software disease have started with the SolarWind Orion event. I don't know if you're familiar with what happened with SolarWind Orion, the Russian hack. So SolarWind is a company that makes software that's quite popular. It's called Orion. It's a management software. And it was hacked by Russia. And the hack that they have pulled off is quite smart. Instead of changing the source code or changing the binaries, it directly attacked the build pipeline. The result is that anytime the developer were committing an update on the source code looked normal. And then the build happened. We already have CI/CD, so it's automated. And then the application was released to the customer, but actually in the build pipeline, you had some kind of Trojan that inserted malicious code in all the binaries. And all those binaries ended up in customers' environment. So this is a super smart approach when you are a hacker. And that was a wake-up call for the industry. We need to secure the software supply chain. We need to secure the build pipeline. It's all about trust. I like to say that compiling an application, it's like source code laundering, basically. You know what you have as input. You see the source code. It's human readable. It's not necessarily easy. It can be quite obscured. But you see the source code. You can audit it. You put it in a compiler, you get binary. You cannot read that anymore. So you need to trust the compiler. You need to ensure that no one has tampered with it. You need to ensure that no one has inserted any hack, any malicious code in the compiler. But it's bigger than the compiler. It's a whole build pipeline, actually, that you need to secure. And you need to have trust in that. And that was the wake-up call, I think. The SolarWind event was the wake-up call in 2020. And that's not the only situation that happened. 1 year after, we had the Log4j event, which is also patient zero somehow. You familiar with what happened with Log4j? So just as a reminder, it's a small binary, small library for Java for log, and everybody used it, and nobody did it in pretty much any Java application. In 2021, we disclosed the vulnerability, which was rated 10 out of 10 in the CVSS scoring, so the worst you can imagine. And this vulnerability had been around since 2013 for 7 years. And the problem was not that it was hard to solve. The problem is that it was hard to know if you even have that in your IT. It was very hard for customers, for companies out there, to know if they had one component, maybe that is not supported anymore, that has embedded that in the Java application. And it was really a wake-up call. Okay, now we need to have traceability. Now we need to secure the supply chain. We need to secure the pipeline. We need to trace everything. Okay, but that's not enough to have the industry that wakes up. You need regulation to enforce that. You need support from your government. So in US, we had many support from the government. You have the Executive Order 14028, National Cybersecurity Implementation Plan. And of course, it percolated down in many other standard bodies, commercial compliance regime. Currently, if you want to sell anything as an ISV, for example, if you are a software vendor, to the federal government or any federal agency, you need to comply with the Secure Software Development Framework from NIST that have many requirements in terms of security of the software supply chain, traceability, notarization, etc., etc. So now we need that. And I don't have to go into detail of EU. There was an opportunity to create regulations. They need that as well. But we see that everywhere. G7 has done some regulation for the finance. We see that pretty much everywhere. Every group has now issued regulation and compliance requirements related to software supply chain security, related to traceability of what you have in your IT. So in this context, if we take a step back, container is challenging. It's easy to lose track. It's easy to have blind spots in container. It's even worse when you talk about Kubernetes application. And we are in a world where we need to fight the mad software disease, and we need it for our own risk management, but also for compliance. But beside that, beside this wake-up call, beside every effort that everyone has been pulling, it's still growing pretty much. As you see, this is the number of malicious packages discovered by Sonatype per year that has some malicious code. 704,000 packages. And the growth is exponential. So how is it that this growth managed to be exponential when everyone seems to react? Well, as the industry matures, so does a hacker. So this is what is happening. So you need to have something secure. You need to source your open source application in a place where you have guarantees, traceability, signature, things to really be at ease and have peace of mind. At the end of the day, that's all we want. We don't want to care about that. We want somebody else to do it. And that's what we're doing. Trusted open source software procurement, that's what application collection is all about. We really want to empower you with tools so that all those questions, and that's really a subset of the question you need to ask yourself, are trivial to answer, and all the answers shall be reassuring. What containers are pulled into your organization? Where are they pulled from? What's inside the container? Who made that container? How is the container created? Does it contain any vulnerabilities? Do you have the right licenses in the containers? Are you in license breach in any way? And many more questions. This should not be difficult to answer. You should have the tool to make it super easy to answer. And that's what we try to do. So we've created SUSE application collection. So from a customer standpoint, it's a distribution platform. Then you have several interfaces. You have the web application that you see here, and we're going to go into detail. I know some people here use Helm as a day-to-day job tool. You want to be able to interact with it with CLI. So of course, you have an OCI conformant distribution platform. Basically, it means a registry. You can do Helm install. We have metadata services because all those traceability comes in the form of metadata. And we want to tool our customers to build automation on that with REST API. And we have security and automation features. So all of that in the distribution platform. So cool, this is what you're going to interact with. But we need it to be a source of truth. What we want is that our customers rely on that, trust that for every of their requirements so that they can really simplify their life, build synergies across the team, reuse components, etc. To build that trust, we have set an enterprise-grade baseline. What our guarantee is that everything you're going to find on the distribution platform has traceability and trusted metadata, meaning signed metadata, provided, generated at build time, etc. Automatability, so that's achieved by standardization and good quality of the data. CV mitigation, so we ensure that we do all that, we apply all the best practices to reduce CV, and we're going to focus on that because it's super important. Security scanning, everything is built. So we do regular security scans, and all of that is built on SUSE foundations. So that's our promise. In terms of content, we curate the most popular open source applications for Kubernetes needs, and that we maintain them so that they're always up to date and secure for you. And behind the scene, it's all made with our robust build pipeline. Fully automated, meaning if anything, if there is any release from the upstream open source project, we rebuild automatically in a matter of hours, sometimes less, so that you already have the freshest version possible. But we don't do just that for the flagship application. I told you for a typical container, you have 40 or 50 packages. If any one of those packages has a new release upstream, we automatically rebuild the package, and we rebuild all the containers that include this package. So you're always on top of the freshest version with all the security fixes. We have a SALSA level 3 grade build pipeline. That's super important. Allow me to go a little bit into detail here. SALSA is a framework of best practices to build applications. It stands for secure software supply chain level 4 artifact, software artifact, something like that. I'm not sure I remember precisely, but it's about secure build. It was initiated by Google, but now it's an open source popular framework. And it basically says to build a trust on the build pipeline, we need to apply best practices. And the best practice, the highest level that there is on the SALSA framework is level 3. And of course, we are at level 3. What it means in practice is that whenever we build something, we first start by pulling the source code and notarize it and ensure that we have trace. And then we create a virtual machine that doesn't have any network device. So it's really isolated. We build inside this virtual machine, we do all the signing, etc., and then we destroy it. It's ephemeral. All that to ensure that no one can tamper with it. All that to ensure that it's secure. And then, of course, we keep track of everything, we sign everything, and everything is scripted. This is the highest possible level of security in the sense of building. And that gives you peace of mind. Ultimately, all of that is technicality for peace of mind. It's based on the same tooling as our SUSE Linux, and that's important because I don't know if you're familiar with that, but SUSE Linux is the only general purpose operating system that has reached the common criteria EL 4+ certification. So some very technical like that, but what it means, common criteria is the most popular and broadly recognized framework for security certification. Level 4 is the first level that includes software supply chain. So we have the only build pipeline in the world that is able to build a general purpose operating system, so any technology stack, basically, that's what it means, and reach a level that is granted by the common criteria in terms of software supply chain security. And we use the same tooling for application collection. So you rely on basically the best in class. And we generate all the metadata as you need, because when you have built something trusted, you only did half of the job. The other half is to provide the proof of that, the evidences, and this is the metadata. So let's take a very simple example, something that is actually available in the application collection. It's called Apache API6. Maybe some of you know. It's an API gateway. Apache API6 is not any project of enthusiasts in their garage. There is actually a company behind it. It's called API 7. And API 7 provides an official Helm chart. So there is an official way, endorsed by the company behind the product, to install that in Kubernetes. And here is what it looks like. You have one main Helm chart, and you have 3 subcharts. The first thing you notice is that, actually I have a clicker. Yeah, cool. The first thing you notice is that one of the Helm charts is not built by API 7. It's built by another company, by Bitnami. We live in an open source world. We check things that are available. So they decided that instead of building themselves the etcd Helm chart and the containers, they would rely on something else. And then all of the Helm chart pull containers from Docker Hub, which is basically the Far West. And when you try to look what's inside, you'll see that on those 4 containers, you have 3 different operating systems: Debian 12, Debian 11, and Alpine Linux. And if you start to scan that with a vulnerability scanner, such as Trivy, for example, this is what you find. And you don't have to trust me. This is public information. You go on Artifact Hub. This is available on Artifact Hub. You just type Apache API 6, and you'll see 396 vulnerability as of this morning, including 16 critical for just one application. Now replicate that with all the application you need, because this is just the API gateway. You also need maybe a database, you need a web server, you need an identity provider. This is not sustainable, this is not enterprise grade. And here is what it looks like when you take our version of Apache API 6 in application collection. So what you see, we just follow open source. We do not change the source code. We just use the same source code. So we have the same approach. We have the 4 Helm chart. But where things are different is that all those containers, they built by us. They built with libci as foundational layer. We update every dependencies automatically every time there is a CV that is fixed upstream. And the result, single trusted source, single secure base OS, a lot of standardization, a lot of homogeneity, so ability for you to automate, to enforce policy, etc. And we have only 11 CVE, and 0 of which are critical. The remaining CVE are related to things that are not yet solved upstream. Well, that's as of today. So you see the benefits you get just by relying on best practices. We do not change source code. We just apply the best practices in updating the dependencies automatically and ensure that everything is built on a robust foundation. So this is what we're doing. And these are some of the foundational principles that we apply to ourselves. Up to date in hours. So the whole automation principle we've set in place enables us to update every time there is something that is happening in upstream in a matter of hours. And we say hours because we don't want to be sued, but it's actually very often less than 1 hour. So we can really reduce the time where you are exposed to a CVE. Provenance. We ensure that we provide you complete visibility and control with JSON-based detailed reporting, so you can really automate on that for the origin and the history and the licenses of every component in the container. So that's how we can really empower our customers to be able to control the environment, to secure the environment, to audit the environment, to prove things. So if you have a risk management entity and they come to you and say, hey, what's inside your environment? How much time did you take to update this? You have the data. It's available, and it's available through, of course, the traditional in-toto attestation you can get through Cosine, etc. It's also available through REST API if you want to automate on that. Best security practices, of course, it's built on the best practices around. We talk a lot about that. We do vulnerability scanning automatically, regularly. We have antivirus scanning, etc., etc. And it's optimized container. We all know that footprint matters when it comes to the Kubernetes world. We talk about clusters. We talk about hundreds, thousands of computers. So the same binary, the same artifacts, you don't want it would be manipulated by hundreds of machines. You don't want it to be too big. That's one reason why we are using an optimized container. We make it small. But that's not the only reason. Having a small container means also having small attack surface. So less CV, less risks, once again. I have a little bit more of those marketing goodness. So everything is up to date, of course. We have continuous vulnerability scan, signing, everything is scanned. OCI conformance, that's important as well because Kubernetes is still a very young environment, and not everything really follows the OCI specifications. We really wanted to do things the best way so that it's sustainable, so that we do not change every day, so that you don't have to interpret anything, and you can rely on the way we work with the OCI specification. So it really is fully OCI compliant. We have flavored content because sometimes you want, I don't know, Apache Tomcat with latest version of JDK or another version of JDK. So we have several flavored content for that, and everything is optimized. Multiple application types. You find Helm chart and single containers. Multiple architecture, x86 and ARM64. Level 3 compliance, I think I already told you a lot about that. Software bill of material. So software bill of material is really the cornerstone of traceability and liability in matter of supply chain security. So we provide them in two formats. The two formats that are recognized by the NIST in the US, the Secure Software Development Framework. So CycloneDX, SPDX. Each of them is recognized. We provide both. We have vulnerability scans that we do automatically, and they are included in the in-toto attestation. We have two of them because we have 3V, which is a de facto standard in the industry. But also, we drink our own champagne, so we use a new vector as well. And we do antivirus scan. So with that, normally, you're good to go. You can have peace of mind. I bored you with all those data, so you don't have to care about that after. You just trust it. So what does it look like? I won't go through the demo. If you want to see a demo, you come at the showcase. I'm doing demo all day long. But I'm just going to show you with screenshot then. It's easier for the discussion. So we have a main page on the web application. And on this main page, you can see the latest edition. So you see we have this news feed. And we have Atom feed. So you can even automate something based on that if for some reason you want to be warned every time something new comes. We have the history of release, so we're really being very transparent on what it is that we have. And when it was delivered, at which time exactly we delivered it. So that gives you an idea of how it works. So that's one day, another day. It's quite recent. By the way, all of what I'm showing now is part of the web application that you can access even if you don't have a subscription. The Helm charts themselves are for Rancher Prime customers. And starting today, you can also get access to it through the AWS Marketplace. But this information, the web application, the metadata, the catalog, everything is available for you to consult. So we can really start to play with that and look at it and see if it fits your requirements. So you can search and filter through the collection. That's quite basic or obvious, but still nice to mention. And then here we start to see a little bit more interesting stuff. So when you pick an application, you see all the branches of this application. We try to follow upstream. So if the upstream community for a given open source project say we're going to support 2 major versions in parallel, you find both of them there. So really, we align with upstream there in terms of lifecycle. For a given release of a branch, you get all the elements of the total attestation and the vulnerability in this page. So you just click on an artifact, and this is what you see. You see the SPDX, CycloneDX, so the SBOM, the SALSA provenance, the vulnerability scans, antivirus scan. You click, you can see the content. It's JSON file, so you can directly download it, etc. Everything is signed. You have the digest, you have the size, and you have the vulnerability scanning. So the result of the vulnerability scanning, and when it was made. You can see the packages. So all the packages inside this container has 39 packages, but we do not just tell you which package, we also tell you which version, but also which license. So this is for convenience, but you find, of course, all those information in the SBOM as JSON files, so you can really automate on that. And one thing that I find quite cool is you can compare 2 versions of an artifact. So you can click on an artifact, and you have an icon in the corner, and you can click on it and see, okay, what was the previous version of this artifact on application collection, and why is it that we have triggered a rebuild? What is it that we've chosen to rebuild it to make a new release? In this example, you see for Apache Tika, you have 2 versions. They have 10 days of difference. What we changed, the dependencies, not the application itself. As I told you in the beginning, we do not just update when the flagship application is updated. Here, the flagship application hasn't changed, so there's no release of Apache Tika that has happened in these 10 days. But there were releases of libx11.6, libx11 data, and OpenJDK, so we updated the container. So it's really about updating dependencies every time we can. So what's the next step? Well, you can get it now. If you are a SUSE Rancher Prime customer, it's already available for you. It's part of your subscription. You go on application collection, apps.rancher.com, and you can start play with it and deploy it on your Rancher deployment. It's also available since today in AWS through the AWS Marketplace. So you can purchase a subscription, and then you can connect and get all those goodness. And of course, you can see it live, apps.rancher.com. You can see all the things we went through. And if you want even more goodness, you can come and see us at the technology showcase. That's it.